Hello and welcome to Chapter 4, Section 3 of your Trig course on vectors. And we start this off with our objective here, and I know you can read your PowerPoint and telling us what vectors are. I just want you to know that these PowerPoints are in your lecture notes, and you can print these off and you can look at them and refer to them as you go. I'm going to go ahead and just look at some of these questions that they're going to ask you on your homework. And the first one's just kind of vocabulary. It says a blank is a quantity that has magnitude and direction, and that's a vector. A scalar is a quantity that has magnitude but no direction. The vectors that appear to be equal are going to have the same magnitude and the same direction, and that's going to be B and B. Mark those. Number 4 says, refer to the figure, the vector that appears to be scalar, multiple of V. When the scalar is positive, that means it's going to go in the same direction. But the scalar is not 1, so it's going to make it a different size, and that is going to be A. It's going to be in the same direction, meaning it has the same slope. Or on a graph, you could find the slope, and it would be the same direction, but it would be a bigger size. This says which one appears to be a scalar multiple of V when the scalar is negative, which means it's going to go in the opposite direction. So this would be V and W are going to be opposites. The vectors I and J both have magnitudes of 1 and are called unit vectors. The direction of a vector I is along the positive x-axis, and the direction of vector j is along the positive y-axis. So we're going to bubble in unit and x and y. Consider the following vector from 0, 0 to AB. The horizontal component is A, the vertical component is B, and the magnitude is given by the square root of a squared plus b squared. This is very similar to the distance formula to Pythagorean theorem. So we get these bubbles. The vector represented by these brackets that look like sideways V's is a position vector because it has its initial point at the origin. Vector V with points x1, y1, and x2, y2 is equal to the following vector, and it's going to be x sub 2 minus x sub 1 right in here, and y sub 2 minus y sub 1 right in there. So let's apply some of this. So here we have the vector is a sub 1i plus b sub 1i, and the w is a sub 2i plus b sub 2i. Then the following are true. For their sum, if you're adding vector v and vector w, then it's a plus a sub 1 plus a sub 2, and then b sub 1 plus b sub 2. If you're subtracting them, it is a sub 1 minus a sub 2, and b sub 1 minus b sub 2. If you're multiplying them by a scalar k, then you're just going to multiply k times the a value and k times the b value, which would be a sub 1 because I'm in vector v, and b sub 1 because I'm in vector b as well. For any non-zero vector, the unit vector has the same direction as v, and this is my formula for that. To find the vector, divide v by its magnitude. So see slide 29 for an example. So I'm going to go to slide 29 and look at the example here. Here's the example where they found a unit vector. You can stop the video and you can look at that if you need to. I'm going to go back to full screen here. Slide 30 talks about this. I'll scoot over there really quick after I read it. It says, let V be a non-zero vector If theta is the direction angle measured from the positive x-axis to v, then the vector can be expressed in terms of its magnitude and direction, where the magnitude times cosine theta I plus the magnitude times sine theta j. So let's go over to slide 30, and there's where they're explaining that, and they're giving you an example. So you can stop the video and look at that example if you need to. Go back to my other screen. We're on number 13. If F1 and F2 are two forces simultaneously acting on an object, the vector sum is called the resultant. Okay, U and V have the same direction. Find the magnitude of U and the magnitude of V. You can magnify to enlarge this graph, but you're basically using the Pythagorean theorem if you want this into a right triangle, or you're either using the distance formula to find the length. So you are going to have the square root of 53 for each of those vectors. Are they equal? Yes, they are. They have the same magnitude, and they're going in the same direction. You can also count out the slope from there. 15 says sketch the vector as a position vector. I'm going to go back really quick and show you an example of that because I want to be sure you have that. There's your force, and I don't think they have an example over there. So you click on, if you need help, click on the button that says show me an example. Sketch the vector as a position vector. It's going to go through the point 3, 2. So I went to 3, 2 on my graph, and there it is. It's going to be the magnitude. Here's the formula for the magnitude. It goes through 0, 0, and 3, 2, and I just plugged that into that formula, and I got the square root of 13. Number 16, to sketch this, it's the same thing. It's going to go through the point 4, negative 4, because remember this is your x coordinate and this is your y coordinate. And then to find its magnitude, I use the point 0, 0, and 4, negative 4, and the distance formula, and I got 4 square roots of 17 says let v be the vector from point 1 to point 2. Write v in terms of I and j. So here we go, and to do that, remember our formula says x sub 2 minus x sub 1 plus y sub 2 minus y sub 1. So I just plugged those in, and I got 8i plus 16j. Number 18 is the same type of problem. Here's where I've worked it out. Number 19 gives you these 2 points. I've worked this out. Number 20 gives you U and V, and they want you to add them together. To do that, you add the coefficients of I, and then you add the coefficients of J. Everything you do with vectors is pretty straightforward. 21, same type problem. 22, they're asking you to subtract, so please be careful when you plug that in. Negative 9 minus 3 is negative 13. Negative 4 minus that negative 7 is going to be 10. 23 is multiplied by a scalar, so you just basically use the distributive property. Multiply that 7 times each of those values. Same thing here on number 24. Number 25, worked out right here. It says let v equal negative 3i plus 8j and w equal negative I minus 9j. So I'm going to multiply each of these by the scalar, and then I'm going to subtract them. And this is what I get. This is where I've multiplied the first one by 5 and the second one by 4. 26. Find the magnitude of 2v. First you have to multiply by the scalar 2. And then find the magnitude using the magnitude formula, and I get 4 square roots of 5. 27, find the magnitude of w minus u, is what the problem asks for. So the first thing you have to do is find w minus u, and then you find its magnitude. 28, 28. 28 says to find the vector that has the same direction as v. So you're going to have to use this formula, v over the magnitude of v. So I find the magnitude of v, and I basically just use that as a denominator for each of these parts. 29, find the vector that has the same direction as vector v. Same problem, same formula, same process. Find the magnitude of v, and then you're going to have to rationalize the denominator here because you're going to have a radical in the bottom. Number 30, notes. Here's number 30. Write the vector in terms of I and j. Okay, so there's the formula. It says v equals the magnitude times cosine theta I plus the magnitude times sine theta j. And they give you the magnitude. So you just plug this in. They give you theta is 30. So you know the cosine, you know the sine. And when you simplify, this is your vector v. 31, same type problem, except we're using a different theta. Theta is 45 here, so it's both its sine and cosine are square root of 2 over 2. And this is what we get when we simplify. 32, u and v and w. And basically, you just have to take your time. The first thing we need to do here is we need to find 2u. So I'll do that. And the second thing I need to do is find 4v. And then 4v minus w. And then I subtract that from the u. So you just take your time working through those problems. (33) is worked out here. You've got u and v, and you need to find the magnitude of u plus v squared minus the magnitude of u minus v squared. So you find u plus v, you find u minus v. Then you find their magnitude. When you square it, it cancels out that square root. Y'all, that's a 58. Hard to tell, but that's a 58. And so you get this value, 58 minus 162, which is negative 104. On 34, you want the magnitude and direction. So you want to find the magnitude. You do that here using the magnitude formula. To find the direction, that means the angle. You want the tangent. Well, you know the y value and the x value. So you put that in and you get negative 70. Y'all, negative 70 is down here in quadrant 4. So you have to think about where you're at. If x is negative and y is positive, then you're actually up here in quadrant 2. So you have to do 180 plus the number you get. You have to add 180 to that to get your 109.7. Then the last problem gives you v. They want the magnitude, and you put that together and use your magnitude formula. Now, you're going to get 0 on the bottom when you're trying to find the tangent. You know that's undefined, but we know that that happens when the angle is 90.